Today, we are going to understand a very interesting and important topic of mathematics. At first, this topic may look a little new, but we use it many times in our daily life. This topic teaches us that the answer to every question can also be found by going in the reverse direction. Just like we see the result of some work and then think about how that result came. This very thought takes us to today's topic, so listen carefully and keep your mind calm. Now let us begin with a small story. Suppose you are climbing a mountain path. You remember the path and you easily reach the top. But when you want to come down, it is possible only when the path is clear and unique. If there are many paths at the same place, then coming down becomes difficult. In mathematics also, some functions are like this. They show the forward path, but the backward path is not clear. This is where the idea of inverse is born. Now let us understand this in the language of mathematics. If a function f from a to b is 1, 1, and onto, then an inverse function f inverse from b to a exists. For x belongs to a and y belongs to b. If y equals fx, then x equals f inverse of y. Trigonometric functions like sinx, cosx, tanx are periodic functions. These functions are not 1, 1 over their complete domain. So inverse functions of trigonometric functions do not exist globally, but on specific restricted intervals, these functions become 1, 1, and onto. Therefore, inverse trigonometric functions can be defined only on those restricted intervals. Before defining inverse trigonometric functions, we must revise domain, range, and period. For sinx function, domain is R, set of real numbers. Range is closed interval minus 1 to 1. Period is 2 pi. For cosx function, domain is R, set of real numbers. Range is closed interval minus 1 to 1. Period is 2 pi. For tanx, domain is R minus 2n plus 1 times pi by 2, where n belongs to set of integer. Range is R. Period is pi. For codomain is R minus n pi, where n belongs to set of integer. Range is R. Period is pi. For scx, domain is R minus 2n 1 times pi by 2, where n belongs to set of integer. Range is R minus open interval minus 1 to 1. Period is 2 pi. For cscx, domain is R minus n pi, where n belongs to set of integer. Range is R minus open interval minus 1 to 1. Period is 2 pi. None of the standard trigonometric functions are 1, 1 over their full domain, so inverse functions do not exist over the complete domain. When we restrict the domain to suitable intervals, the functions become 1, 1, and onto. Such inverse functions are called inverse trigonometric functions or inverse circular functions. Now let us connect this with real life. Suppose a fan is rotating in a circular path. It passes through the same point again and again. If you see only its shadow, you cannot tell how many complete rotations it has made. But if the fan is allowed to rotate only from 0 degree to 180 degrees, then each position becomes unique. Now, you can easily identify the angle. This is the real meaning of domain restriction. Now let us see a sports-related example. In cricket, a speed gun shows the speed of the ball, but only by looking at the speed, we cannot decide the angle of release of the ball. From different angles, the ball can move with the same speed. Only when the bowler's action is restricted, the angle can be predicted. This is also the idea of inverse function. Now understand one simple example. Suppose there is a vending machine. If 3 different codes give the same chocolate, then you cannot say which code was entered. But if only one code is allowed, then the answer becomes clear. The same thing happens in mathematics. Inverse is possible only because of domain restriction. Now finally, let us understand what we have learned. We learned that the inverse of a function is possible only when the function is 1, 1, and onto. We learned why it is necessary to restrict trigonometric functions. This topic becomes the foundation of calculus and higher mathematics. If you understand this concept well today, your future studies will become easier. Remember, mathematics is not a subject to fear. It is a subject to understand. Keep practicing, keep asking questions, and maintain your confidence. Today's lesson ends here. Keep smiling and stay friends with mathematics.